I'm going to try to keep it to just this class's questions. And let's see, the first question we got, here's one. This is 3.1, number 13/7. And they're probably like the difference quotient, except they use -a, and that's a big deal. Some books use it a lot, and then some don't use. Some use. Let's see. A projectile is fired vertically upward into the air. Its position in feet above the ground after t seconds is given by the function. Use limits to determine the instantaneous velocity at t is equal to a. And t is equal to a is 2. A is 2. It's just like x. And we're just going to, I'm going to write the question down. Go ahead and write it down. I'm just going to write the function. S of t is equal to -16. This is a test question. T squared plus 100t. And a is equal to 2. Now, 0 feet per second. I don't think that's true. No, I didn't think so. Because when you plug in 2, you should get the answer. 2 squared is what? 2 squared is 4. 4 times 16 is 64. Yeah, that would be the instantaneous velocity at. Determine the instantaneous velocity of the projectile at t is equal to a seconds for the given value of a. Yeah, let's draw the function. I'm going to draw it with the calculator. So graph clear, y is equal, clear, and clear. And that's going to be -16 x squared plus 100x. And graph. And I'm going to do a zoom standard, zoom fit, and zoom quadrant 1. I still don't like it, so I'm going to do a zoom fit. And I'm going to blow it up. Zoom out. And I'm going to put y right about there. And now I'm going to blow up, zoom box. And I'm just going to blow up this area right in here. There. And then, of course, we can see that it's going from second trace. We can go ahead and get the maximum. I'm going to just go ahead and get all this stuff right now because I don't know if it's going to ask for it or not. The vertex is somewhere in here. There's the vertex. So we've got the vertex is 3 at 3.125 seconds. 3.125 seconds. The projectile is 156.25 feet or distance in the air. Let's go ahead and check out the 0. So second trace 0. And go over here. That's the left. That's the right. And that's, and at 6.25 seconds, it hits the ground and is at 0 vertical feet. And this is 0, 0 where you, okay, so I just drew this, and you can hit second table and you can find whatever you need to for those points. At 2 seconds, it's equal to 136 and so on. Okay. The instantaneous velocity, that should be the first derivative, but I don't know. They haven't, they looks like to me that you would at least do the first derivative. Yeah. And that's where we do the limit. And this is another way of writing the difference quotient. So limit instantaneous velocity is equal to S of t minus S of a over t minus a. Now, if you go back and do this problem, look at what I'm doing here. Well, I guess I'm just going crazy. There we go. This is the same thing as f of x. So it's a little bit different from the difference quotient. Since this function is in terms of t, this is the same thing as s of t. This is the function. So this function right here, we're going to color it blue because it's going to go first. The function is going to go first instead of xs plus h. So this is the function, is first. So I'm going to plug in negative 16t plus 100t minus s of a. So what does that mean I'm going to do with s of a? If there, wherever there's a t, I'm going to plug in what? A. So that's going to be negative 16a. That's supposed to be squared, isn't it? Yeah. Supposed to be squared. Plus 100a. All that over x minus a. And I'll do that in, or t minus a. And that's going to give you negative 16t squared plus 100t plus 16a squared minus 100a all over t minus a. And that should be what they're doing right here. And if you'll look, that's what they're doing. Now, they actually plugging in 1 first. Now, you can do that first or you can do it second. And then plug in. Okay, so that's what they're doing it first. And you can do that. That's fine. Doesn't matter when you do it. But you're going to get t minus 1 no matter what. So we'll go ahead and, since they did it first, we'll do it first. And we'll plug in the 2. So let me do that first. I'm sorry. So t, I don't do instantaneous velocity a lot. So s of t minus s of a. I'm going to do it again. Sorry. and draw everything out for you, over t minus a. And since we're going to do it first like they did, a is equal to 2. So we're going to plug in a is equal to 2. And that's going to give us negative 16t squared plus 100t minus, well, S of A, you're going to plug in what? You're going to plug in a 2 there, right? And that's going to plug in a 2, and you plug in 2 wherever there's a parenthesis. You can do it before or after. So that's going to be 16 and then a 2 squared minus 100 times 2 over x minus 2, or t minus 2. So that's what happens. Now you could have done that here also. You could have done it here. But since they did it, they're doing it at the beginning, we can do that also. So that's going to be negative 16 t squared plus 100t. And then we've got to do this math here. That's minus brackets. And 2 squared is 4 times 16 is negative 64. Somebody help me out there. And that's negative 64 minus 200. Somebody check my math there, please. Over t minus 2. So what is negative 64? Is that negative 264? But it's a plus. So it's going to look like negative 16t squared plus 100t plus 264. Y'all check me, please. Y'all not going to say anything. Over t minus 2. Now, I don't know if they want to keep going. Let's see what they did, because like I said, I don't do a lot of instantaneous velocities. So let's see what they did. Did they keep going, or did they just, let's see. Okay, they got that, and we got that, and okay, they do want to factor. Okay, so we'll factor out. You can factor out something good there because they're all even. So let's factor out and keep going. So I want to rewrite this on the next page. And that's going to give me, I'm going to write it in black. It's negative 16t squared plus 100t plus 264 divided by t minus 2. Okay, now, what will go into 16,126? Well, let's go over here and write it down. Let's see, 16,100 and 264. And 2, 3, 5, 7, 11, and sometimes 13. Okay, 2, that'd be an 8, that'd be a 50, and that'd be what, 142? That is a 264, isn't it? Let's see. No, that's 264. Okay, that's 2, we're going there one time, 3, 132. And then 2, that'd be a 4 and a 25. And 4 will go into 13 3 times, 34. And 4 is your biggest number. That will go into all of those. I'm going to factor out a negative 4. And that'll give us a negative 4. Will give us 4t squared plus 25t plus, I have no idea, 4, we're going there 6 times, and 4 times, somebody help me out. Let's see.
66.
4, we're going there. So what?
66.
Thank you. And we're going to have to factor this one because there's nothing we can do. Oh, that's yucky. So -4, and then t and t, and the multiples of 36. These 1 and 4, 2 and 2. But we know this is 1, so chances are it's going to be 1 and 4. So 1t and 4t, and 66 is 1, 66, 2, 33, 4, 5, 6, and 11. Okay. That 2 and 33 look good. So let's do a 2. Maybe we shouldn't have factored out a -4. 2 and 33. 2 here and 33 here. What is 33 minus 8? Is 33 minus 8 25? I think it is, isn't it?
Yes, sir.
It is.
And we need to keep that negative. We need to keep that negative in there because that's going to mess up. So let's make that a positive, and then this would still be negative, positive, and negative, right? Did I factor out? No, it's still going to be, okay, there we go, negative. That'd be a negative right here. So that would work. So 4 times t minus 2 times -4t plus 60, or plus 33. That'd be 33. No, that's not right. That's still going to be a plus. We've got something wrong because there should be a sign there. The t minus 2 should cancel. But we got a sign wrong somewhere. Somebody help me out with the signs.
I think it's supposed to be minus 66. Or
Minus
like,
6. That's
it's
what I
supposed
thought.
to be minus 264 instead of plus 264. I'm pretty sure.
Thank you. Thank you. I knew there was a sign wrong somewhere. Yeah, there it is, right there. No, because that negative makes this a positive. See that
But up
negative
there,
right
whenever
there?
you wrote it, and like above that, you put minus 100 times 2. Yeah, right there. But I'm pretty sure it's supposed to be plus. Like you're
Okay.
supposed to put a plus sign right there. Maybe.
There it is, right there. Thank you, ma'am.
You're welcome.
Thank you. I knew there was something wrong because I wasn't getting what I needed to get. All right, so I got 4. So we've got 4. So limit, I don't know what the limit is as t approaches 0 or whatever, but our final answer is 4 times 4t plus 33. That should be what they're wanting. And the limit, let's see what their limit says. Because they got, yeah, limit as t approaches 2. That's what I thought it was. And you plug that in, and that should be what you get. Yeah. So plug in limit as t equal to 2, and that's going to be 4. Sorry. That's going to be 4. I still think that, let's see. I still think we got a sign wrong somewhere. All right, 4. That's going to be 4 times 2 is 8. 8 plus 33. And 4 times, and 8 plus 33 is what? 41. 41 times 4 is 164. That's a little bit much. I think we got a sign wrong. I still think that's supposed to be a negative. But
where you got the sign wrong up top.
Say again?
Where you got the sign wrong up top, that was supposed to be 64 minus 200.
64 minus 200.
I think it's supposed to be 136 and not 260.
Yep, because right where you got the sign wrong up top.
Yeah, right here.
Negative 260.
Yeah, right there. That would be plus 200. Yeah, that's where I got it wrong. Okay, so negative 64 would be 136, and that would be a minus 136, would it not? Y'all check me. Minus 136.
Yeah, that's
Let me start over. I'm sorry. 4 is still, so that would be, somebody check me. 4, negative 16 t squared plus 100 t minus 136 over t minus 2. And I'm going to factor out, and I'm going to factor out a negative 4. Negative 4, and that's going to be 4t squared minus 25t plus 4 will go in there 3 times, and that'll leave what? 30, let's see, 34. Somebody check my math.
Yeah, that's right.
Yeah, that's right.
Over t minus 2, and that'd be negative 4, and we want a t here and a 4t here and a 34. Well, heck, that's 1 and 34, 2 and 17. So chances are it's going to be 2 and 17. So a 2 here and a 17 here. 17 and 8 will give you a 25. That'd be a negative and a negative. Now we're cooking with peanut OIL. Thank you for finding that error. And now that's going to give you negative 4 times 4t minus 17 evaluated at t is equal to 2, which will give us 4 to be 8 minus 17. Oh, heck, I don't know what 8 minus 17 is. 9, and 9 times 4 is 36. So you should get 36 feet per second or whatever the acceleration is. Sorry about that. That's why I tell y'all to check me. But the time to tell me, I do appreciate y'all telling me, but the time to tell me is not, at the end of the problem. I appreciate if y'all would tell me in the middle of the problem. Okay, let's do another one of those because I know you probably have sent several of these. I don't know why they're not doing the difference quotient. I don't know why, but this is instantaneous velocity. It's the same concept, just not done as much. So let's do a nerd. That's that one. I'm going to delete that one. And let me find another. Well, did y'all send any more? Here's one. This is 3.137/16. 3.137/16. Let's see what this one looks like. For the function and point below, find f prime of a. Okay, this is ones we were doing the other day, yesterday. So difference quotient is going to be the f of x is equal to 2 over square root of x. Well, let's go ahead and find our point. Oh, they're doing a again. God darn it. I wish they'd just do difference quotient and not do the instantaneous. It screws me up. All right, so anyway, we're going to have to do it backwards. We're going to have to do f of A, and they're going to use, let's see, f of x minus f of A. That's what I thought. F of x minus f of A over x minus A, limit as x approaches A. Oh. Okay, let's go ahead and do this one. So we've got f of x. I'm going to put that in blue brackets. And I'm going to put the f of A in orange brackets. And the bottom is going to be like magenta. So f of x is right there. So you just write that in blue. So that would be 2 over square root of x. That's blue.
Are we supposed to be able to see what you're writing right now?
Yes, I'm sorry. I suck. All right. Minus. Sometimes I get into writing this stuff and I forget to switch it over. Minus parentheses f of A. So that means I'm going to plug in A is equal to what? A is equal to 1/9. So you're going to plug in 1/9. So 2 over the square root of a big set of parentheses, and I'm going to plug in 1/9. All that over x minus A. X minus 1/9. All right, get to work. Go ahead and do the top. So 2 over the square root of x minus 2 over 1/3 all over x minus 1/9. And that's going to give us 2 over the square root of x minus 2 divided by 1/3 is the same as 2 being multiplied by 3, which is what?
6.
Over x minus 1/9. Well, I believe we're going to have to rationalize this denominator because there's no way we're going to get an x minus 1/9 with this guy. So, God, this is a cluster. This is not a test question. So I'm going to change. That's going to be multiplied by the square root of x times square root of x. So that's going to be 2 square root of x over x. So 2 square root of x over x minus 6 over x minus 1/9 limit as x approaches 2, or what was it 1/9? So that's where we're at right now. And I'm going to tell you right now, that sucks. So we're going to have to factor the top. Gosh, this should be in a calculus class. Oh, it is in a calculus class. Okay. Over x minus 1/9. Now, you know the 1/9 has got to cancel. So therefore, you know one of these is equal to x to the 1/9. X minus 1/9. Yuck. I'm just trying to see. X minus 1/9. But you would have to put right here to get this to look like that. My goodness. I can see why you sent this question. Not to even mention the last, and they're going to annihilate. Well, let me do this. No, that's not going to work either. I was going to do a shortcut, but that's not going to work. I'm thinking, y'all. X I have no idea. I'm gonna have to look and see what they did. They are not playing. They're not playing games here with this question. They're gonna have to. You're gonna have to do some. That's what we got right there. Except we're using 1/9, and they used 125. So they plugged that in. F of x. I'm just looking to see how they factored it. There it is. 2 over the square root of x. Did they rationalize the denominator? Let's see if they rationalize the denominator. 2 over the square root of x minus 10. Okay, they did not rationalize the denominator. That would make it easier. Okay. So where I rationalize the denominator, right here, where I rationalize the denominator, we don't need to do that. So we're going to go back up here. I'm sorry. So I'm going to go back here and I'm going to write this one. 2 over the square root of x, brackets, minus, well, we said that this is 2 over 1/9, over 1/3, which is what, 6? Minus 6 over x minus 1/9. And we could actually go through, and they multiplied by the square root of x. I swear it looks like they rationalized. I swear they look like they rationalized. I rationalized too. God, what an ugly problem. Y'all sure did pick a good one. Are they not rationalizing right here? No. They're multiplying through by the common denominator, which is square root of x, but that's going to cause that on the bottom. And then you're going to have to do, good gracious, then you're going to have to do rationalizing the numerator. Good gosh. Okay, this is a little bit too much. Does anybody agree with me here, or am I barking up the wrong tree? This is just too much.
Yeah, but I tried to do this. I had
know
no
what
idea what I was doing.
Well, don't feel pregnant because this is a little bit too much. Good gosh. All right, so they're multiplying through by the square. I rationalized the denominator, but they're to multiply through, and that's going to give you 2 square root of x times the square root of x over 1 minus 6 times the square root of x over x times the square root of x minus 1 over 9 square root of x. Gosh, what a mess. And of course, the square roots of x is going to cancel. And then that's going to leave you with 2 minus 6 square root of x over x times the square root of x minus 1/9 square root of x. And then they tell you to rationalize the numerator. So that's going to be 2 plus 6 square root of x over 2 plus 6 square root of x. And that's going to be 4 minus 36x. Somebody check that top for me. I believe that's going to be 4 minus 36x. See what y'all get. Over a big cluster, I'm just going to write it x times the square root of x minus 1/9 square root of x, 2 plus 6 square root of x. Did y'all get 4 minus 36x on top? That's going to be squared, and that's going to be squared. That's 4, and that's 36x. So that should be the top. I didn't know these problems were in here. I really didn't. If I'd have known, I would have took them out because that's a little bit too much. A little bit too much algebra. But I guess if it's, I don't think it's necessary. That's what we got right there. Except I distributed the square root of x right there. I distributed the square root of x. And I guess they're putting in 1 over 25. Is that what they're doing now? Yeah. Yeah, that's what they're doing. Well, eventually they're going to plug in 25, aren't they? 1 over 25. Yeah. That's what they're doing because 1 over 25 minus 1 over 25 . You're not going to get a number, that's for sure. You're going to get, that's going to go out, that's going to leave 100. This is a mess. Huh.
I don't mean to butt in, but I think I know how to solve it really easily.
What?
I don't mean to butt in, but I believe I know how to solve it very easily. So since instantaneous velocity is the same as the derivative at a certain point in the function, you can just take the derivative of the original and then plug in.
Well, that's why I don't understand why they're doing this.
I don't think they want you to do that though.
Well, I know they don't.
When I click like view an example.
This is ridiculous. All right, I'm sorry. I know that's what they want to do, and I know that's what they're leading to. But what they're doing is it'd be a whole lot easier if they would just use the difference quotient. And why this book wants to use instantaneous velocity, I don't know. But anyway, they want you to plug in 1/9 now, and that's what you're going to plug in. And I'm just going to write this as 4 evaluated with x is equal to 1/9. I'm going to leave it at that because you're not going to solve it. You're just going to get it down. That's a mess. These are not test questions. But I can understand why you're sending them because they are kind of yucky. I'm just going to put a 3 in there and let you see. I wish we could just get to daggum derivatives because it sure is. They sure are drawing this out. There's the 2 answers when you get finished. Oh, I had no idea they had this much instantaneous velocity questions in the homework. I thought they had the difference quotient. So let me go to the next one and pray that we get eventually to the questions that mean something. Okay, here's one that says, this is AR. I don't know what AR means. Does anybody know what AR means? Is this out of this section or is this in another set? 3.1 says AR.
Yeah, that one was from 3.1.
3 to 12/2. I don't know where this is, but it says write linear equations. I hope they do something that's not write equation of the line containing the given point parallel. Okay, this is a review question. I'll go over it, but why is it in 3.1? Or is this just a review? It says 3.1, does it not? Right there. Do they have review questions in 3.1?
That was only one I found.
Okay. All right. Well, I'm looking at right quick. Let me look at y'all's syllabus right quick. Yeah, 3.1. Okay. All right, 3.1. Let's do this one. And it's just a review question. All right. You got x plus 2y. X plus 2y equals 7 and 0.7, 8. And this is where I would do the two columns or 3 columns. X plus 2y is equal to 7. And I would do perpendicular 7, 8 and parallel 7, 8 and solve for y. So 2y is equal to negative x plus 7 divided by 2. Y is equal to negative 1/2 plus 7/2, negative 1/2 x. And m is equal to negative 1/2. Therefore, what is this one going to equal? What is this m going to equal to go with the parallel? I meant the perpendicular.
It should be the reciprocal.
Opposite sign reciprocal, which would be what? Positive?
2. Should be 2.
2/1 or 2. And what would this one be with the parallel?
Negative 1/2.
M is equal to negative 1/2. Now you got a point and a slope, point and a slope. Use the point slope equation. So the perpendicular would be y minus 8 is equal to 2 times x minus 7. Y minus 8 is equal to 2x minus 14. Y is equal to 2x. Negative 14 plus 8 is negative 6. Somebody check me. And y minus 8 is equal to negative 1/2 x minus 7. y minus 8 is equal to negative 1/2 x plus 7/2, and add 16/2, and y is equal to negative 1/2 x plus 23/2. And that blue is going in the trash can. I don't know which one they asked for, but I do both of them so you can get, extra practice. I apologize for that cluster. Like I said, I had no idea those questions were in there. I thought for sure it was going to be all difference quotient. Were there any difference quotient problems in there? Any in the homework? Okay, thank y'all for replying. Thank you very much.
I think it was all instantaneous velocity.
Was it all instantaneous?
I think so. It was like you found the derivative and then you plugged it back in and made an equation with the slope.
Well, I didn't know they were going to use the, like you said, you could just do the derivative, but that's not what they want you to do. I mean, it's easier to do it that way, but anyway, let's just move on. I want to move on to questions that matter. So let's move on to, how far did we get the other day? Did we just cover constant and power rule?
Yeah.
Okay. Constant and power. So I want to get into the quotient, product and quotient rule today. Product and quotient rule. All right, I'll write them down for you. Now, I'm not going to write them down like the book shows you because they'll lobotomize you. So I'm going to write it down the way Hubert learned it. First times the derivative of the second plus the second times the derivative of the first. How many of you ever seen that before? Anybody? Nope. That you very rarely see that because that's one of the things I'd come up with as a student. Now, did I come up with it? No. It is something that a lot of students do. After you look at the let me show you. I'm not going to show it to you just for a few seconds. Derivative product rule. Once you see, let's see, the derivative product rule, where is it? Here it is. First times the derivative of the second plus the second times the derivative of the first. Now, once you look at that a couple of seconds, it'll brain fry you. So I don't teach that. I don't teach that at all. So let me go to the handy dandy 3.4 homework. And let's look at some. If I can ever get there. Oh, me, 3.4. Those things made my head hurt. All right, here's a good problem. It's a good test question if they didn't screw it up. This book has a tendency to screw up decent problems. All right. There is, and this is the type question I'm going to ask. You can do this two different ways. Okay? So write that question down. A and B, because that's what I do like to ask these on a test. you're going to see where your algebra pays off here. So, I'm going to do A on the first page. Use the product rule. Okay, my problem is 5 minus z squared. 5 minus z squared times z cubed minus 3z plus 5. Which way do we read?
Left to right.
So which one's your first?
5 minus z squared.
Okay, so I'm going to put that in, and that's going to be my first. And then that leaves this as the second. Y'all ready? To get my pink marker and my yellow marker. All right, here we go. First times the derivative of the second plus the second times the derivative of the first. Now those little marks are telling me that I got to take the derivative of this one and I got to take the derivative of this one. And that is the product rule. So let's go ahead and do 5 minus z squared. That just comes down. I don't like this pink marker. Hold on a second. Here's another one. Yeah, that's better. 5 minus z squared. And now I'm going to take the derivative of that yellow right there. And that's going to be 3z squared minus 3 plus the second times the derivative of the first. Be negative 2z. And now what is it? 100% what left?
You have a work email.
100% what?
Algebra.
Algebra. So get to it. You only did one line of calculus. Oh my gosh. Wow. Now that stock's gone up 235%. Daggone. Them hedge funds are really hitting it today. I wish I bought 300 instead of 30. Dang. All right. I still don't like that pink. Let me do this pink. So, well, I'm gonna do black because I'm putting them back in first. That's 15z to the second. Outer minus 15. Inner negative 3z to the fourth. And last, positive 3z squared. And somebody please check me to make sure I didn't mess up anywhere. And since this is plus, we don't have to worry about it messing up, so we can just keep on going. Negative 2z times this is negative 2z to the fourth. Positive 6z squared minus 10z. And I need y'all to check me, see if there's any problems. I wish my Dogecoin would take off like that. Dang, Dogecoin.
How'd you get the negative z to the fourth?
Where?
On the first one. After the negative 15, how'd you get the negative? Yeah, that one. How'd you get that one? Oh, is that? Oh, okay, never mind.
Inside, 3 times z is negative 3, and z squared is z to the fourth.
Because, okay.
Okay, 15z squared. There's a z squared. There's a z squared. So 15, 18, 24. Somebody help me out. 24 z squared. And we got a z to the fourth right here. And a z to the fourth right there. Negative 5z to the fourth. Minus 10z minus 15. And that's going to be negative 5z to the fourth plus 24z squared minus 10z minus 15. That's what I got. Now, I'm going to take my handy-dandy green highlighter, and I'm going to highlight the area where y'all did the calculus. Y'all ready? Okay. From this point right here to this point is calculus. There's your calculus. The rest of it is what?
Algebra.
And that's supposed to be a U, isn't it? Calculus. Rest of it's algebra. Now do you see where students fail calculus? They don't fail calculus because it's a new subject. They fail calculus because they can't do this. That's a good test question. Let's do a nerd. Let's check that one to make sure we know what we're doing. I ain't doing all that. They just forget it. I'm not going to go through and tell them what the first and the second is. I thought they were wanting an answer. Y'all do that one and tell me if we got it right, but I think we did. Let's go do another one. All right, let me show you the quotient rule. The quotient rule. Denominator times numerator prime minus the numerator. times the denominator prime all over the denominator what? Squared. There's the quotient rule. Now, how many of y'all said the other day that y'all had calculus in college before? Anybody?
Just me.
Well, did they write it like that?
They did not, no.
No. And that's one reason students get confused. If you just talk and let the theory drizzle in later, but if you try to hit people that's just coming out of high school with theory, they're going to look at you like you're a Martian. You got to let the theory trickle in later. All right, so here's our question. This is example. I did an example for the product rule. Here's our example for the quotient. H of W is equal to 3W 6 minus W over W Clem's on. There you go. Miss Brown, you're making me dizzy. All right, let's do that one. Let's do it. What do you mean do it, Hubert? We'll plug and chug. Here we go. I'm going to use pink for the denominator. And I'm going to use green for the numerator. And here we go. Denominator times numerator prime minus why did I add that negative brackets in red? That was the communication point, but y'all don't communicate, so y'all just eat Tide Pods. Y'all don't communicate. Over denominator squared. All right, I've just plugged in everything. Now go to it. I want you to try to finish it now that you know what to do. You've plugged in everything. Now just do it. So W times, well, this is going to be 6 times 3 is what? 18. W to the 5th minus 1 minus brackets 3W 6 minus W. What's the derivative of W?
1.
1. All over W squared. Okay, now it's just a matter of you doing algebra. So I will take my yellow highlighter and I'm going to highlight this area right in here. There's where the calculus is being done right there. Now we just do algebra. So 18W minus W minus 3W plus W over W squared. And what's 18 minus 3? 15 W. And what happens to the W's? They go out over W squared. And that gives you 15 W to the fourth. And I can't believe that one came out like that. Question, gripe, complaint. Now we are in the root of the test right here. These two problems we just did with the power rule. Now you're talking about the test. These are test questions. And I'm going to make sure you get at least 10 or 15 of these on the test. Okay, I'm not going to do all that, but let's see, which one is it? Looks like this one, isn't it? I think it's that one. Check. Yes. What is the fully simplified result? 15W to the fourth. Look there. There she goes again, going through the house. Are you showing your house to be sold, Miss Brown? I believe she's selling her house.
No, sir, but can I be excused? I have to be at work in like 7 minutes.
Go right ahead. Are we over time?
Yeah, it's 123.
Yes.
Well, see what happens when you don't communicate? One of these days, y'all want to start communicating and quit being weaned on a pickle. All right, now you can start working on that homework. 5.3 and 3.4. Those are test questions. So go ahead and start working on 3.3 and 3.4. Let me check the roll. And as I check the roll, I just got to check a few names.